The next question we need to address is, what is this Flowgorithm thing? And Flowgorithm is a learning tool that allows you to make working programs of a very simple sort using the visual symbols from a flowchart diagram. And in the early days of computing, flowcharts were used extensively to help design, engineer, and diagram the design of a computer program and to illustrate your logic. And it's very useful because seeing things visually is the way a lot of people work best. Not everyone is a visual learner, but a lot of people like to express things visually, spatially. It makes it quick to, at a glance, understand what's going on with something. Now, some shops still do quite a bit of flow charting. Others have gone to other methodologies for documenting or creating their program designs. But we're going to learn the art of flow charting. It's particularly useful as we train our brains to do something that's a little unnatural for human beings. Since we're intuitive creatures, we tend to go from one thing to the conclusion of that thing without having to consciously step by step, all of the individual pieces that were required to get to the conclusion. Computers can't work that way. They have to work procedurally, step by step, item by item, with nothing omitted, and everything has to be precise and correct. We, however, can train our brains. That's the most plastic and elastic computer we have, and the one we're used to programming first. We can train our brains to do things in a highly detailed order. It just takes practice, but it doesn't come naturally. And so I think that this Flowgorithm tool is really helpful in building the logic and helping us to see what we need to do step by step. And what I really like about it, as opposed to just giving you a drafting template of Flowgorithm or flowchart symbols and having you draw them, is that when you draw the logic that you intend and it is correct, it will run correctly. You can actually run this as a program. And so let's see how that works. So you can test things even if you're working in the middle of the week or 2 in the morning. You can test your ideas out to see if your basic program logic is correct. And you'll recall from our discussion of Visual Basic that and in Visual Studio that the programmer's editor can use IntelliSense to tell us if our syntax is wrong. If we spelled something wrong, it can be very helpful. But it can't detect if our logic is unsound, if we're thinking something that's foolish or untrue. Okay, so let's see how this works. I have the basic Flowgorithm template open. This is what you get when you open a brand new Flowgorithm project. And if you right click on the flow line, you will find that there are different programming symbols, flowcharting symbols. And here we're going to replicate our hello world. So I put an output there. And now to program that symbol, if I left click on it twice, it says enter an expression below. Okay, so I want to enter a string literal or text literal, and that's in quotes. I would like it to say capital H-E-L-L-O, comma, capital W-O-R-L-D, exclamation, and then I need to end that with a quotation mark to tell it that this is a literal text value. It's not a variable I'm referencing. That's part of our syntax convention. That's part of what the Visual Basic grammar requires. And I'll say OK. And that is a complete program. Let's test it and see if it works as intended. So I tell it run, and lo and behold, here is our console output in Flowgorithm, and it output the message hello world, which is indeed all that we asked the program to do. So that appears to be working correctly. So that's what the Flowgorithm tool is. It has tools and symbols that allow us to build the more complex logic structures. So it has flow of control, so we can look at things like input, output. We can declare variables, assign them, put in decision control, call subroutines, and then we can also, let's move this over a little bit. And now you can see it. We can also put in iteration and looping and our decision structures. So decision structures like if, our looping structures like while a condition is true for some specified number of uh, iterations, and the do loop, which will say do something until a condition changes, until it becomes true or becomes untrue, or some other condition is satisfied. And we'll learn all about those going forward.